Hello, mathematicians. We are up to episode 4 today, looking at measurements, and I've broken it down, again, just going over some brief, important parts of it. Okay, so we aren't covering all of it, just some parts I'd like to remind you about. So the 4 different parts within the measurement topic are listed here. So we've got practicalities of measurement, then you've got the actual measurement stuff, which is perimeter area, surface area, and volume, all of your trigonometry, and then the smaller topic of working with time. So I want to do, out of these 4 topics, the most important parts out of each one. The first one we've got is practicalities of measurement. What I have up here is somewhere here, the reference sheet. So I'm going to keep coming back to this so you can be reminded what you do need to remember and what you don't. When it comes to our practicalities of measurement, that is under this little heading here, limits of accuracy. It's all we're given is this. So let's have a look now, what you need to know. The way I always explain this to someone is basically practicalities of measurement and absolute errors. They're just talking about, well, how accurate is the measurement? If I have a measurement of, let's just say 2 centimeters, okay? So what we say is that could have, technically, it could have been rounded. So I could have said it could have been up to 2.5 centimeters or down to 1.5 centimeters. So not including the 2.5, but it could have been anywhere in between or including the 1.5 here, because it would have all got rounded back. If I said round those numbers in between to the nearest whole number, it would have been rounded back to 2 centimeters. So all it's saying is it could have been 2.1 or 2.49, okay? Again, all those decimals in between could have been, if I asked you to round it to the nearest whole number, it would have all taken you back to 2 centimeters. And then the same all the way back here. If I had 1.500006, again, every infinite amount of decimals would have rounded you back to 2. So when we talk about an error, an absolute error, it's saying, well, what is this measurement error? Okay, so what we say, well, it's plus or minus 0.5. Okay, that right there is your absolute error. And hopefully you can see how that is, because we say, well, there's an error up here by that amount and down here by that amount. So it's not always going to be nice numbers though, okay? Think about if I had the number 1.003, okay? Suddenly, the absolute error is a little bit harder to think about. So they developed a formula, and that formula is what was on here. It says the absolute error is half times by the precision. I sometimes call it the limit of reading. So we can always find it by doing half times by the precision. What is the precision? The precision, it's a weird word to keep saying. The precision is, well, what are they measuring? So the precision of this first example we did, if I had a measurement of 2 centimeters, we'd say, well, the precision, they are measuring every 1 centimeter, okay? The precision of 1.003, well, they're measuring every 0.001 of let's say these are millimeters, okay, of a millimeter. So if I give you a 6.5 kilometers, they're measuring every 0.1 of a kilometer, okay? So that is your precision, is what are they measuring in terms of. So this first example, if we follow that formula, it says a half times the precision. So I'm going to do a half times by 1, which gives me 0.5, which was this number here, okay? So that's the formula for those ugly numbers. So now I could just take half times by each one of these precisions and get my answer for what the absolute value is, okay? And that one, you get that. This one, and I just show the working to the marker. Okay, so they are your absolute errors. So whenever it asks you for that, you find the precision times by a half. And notice on the formula, actually it doesn't even have it on the formula. Generally though, we write plus or minus in front of the absolute error. Okay, because of that reason, it could be up by 0.5 or down by 0.5. So that's how I always explain absolute errors. So you get the formula. What you don't get though is the percentage errors formula. All right. So the percentage errors formula is something you need to remember, and it is the absolute error, divide that by the measurement they gave you times 100. So let's take it back to my very first example. If I wanted to find the percentage error of this question, we would take our absolute error, which we worked out was 0.5. We would divide it by the measurement. They gave me 2 centimeters, and then times by 100. Okay, so it's just as simple as following a formula. Timesing it by 100 just turns it into the percentage. So that would be my percentage error. All right, which makes sense because 0.5 is our error and it's a quarter of 2 centimeters. Okay, so that's our percentage error. So anytime you need to find the percentage error, you need to remember that formula. All right, it's pretty straightforward. Absolute value over the measurement times 100. Okay, they are the main parts. The last thing I just touch on is just a harder question of how they could ask that is something like, I've seen it a few times now, where they might give you a swimming pool. And they say, okay, the length of the swimming pool, we are 8.3 meters by 2.04 meters. And they might say, what is the absolute error for the area of this swimming pool? So they want to know the absolute error for the area. To do that, always find your absolute errors of either side. Now, one thing I didn't talk about was just if they ask for an upper and lower limit, okay? The upper and lower limit is just the top and the bottom number. So the upper limit of this question we did up here, it's just going to be 2.5. The lower limit of this question is 1.5, okay? So that's where they develop these formula here. So the upper bound or upper limit, it's going to be just your measurement plus your absolute error because we took the 2 and we add our absolute error and we got up to 2.5. So it's the highest limit. And then vice versa for the lowest limit, okay? So instead of me saying the absolute value, the absolute error, the more common question they're going to say in terms of your area is what is the maximum possible area or what is the minimum possible area for this swimming pool. So the maximum possible area is just your upper limit of the values. The minimum possible area is your lower limit of the values. So let's think about this. What you want to do is do them individually first, okay? So the first thing I would do is find what my upper and lower limit is for each measurement. Once you get better at it, it'll come to you a bit quicker. But this one here, here's my lower limit and my upper limit. Now, oh, sorry, I should have a 0 in there. Now, with this, you would find those answers by finding your precision, timesing it by 1/2 to get your absolute error, then adding it and subtracting it. Okay, so that's how you would have done that. And to show my working, here it is. And this is exactly what I'd show the marker. Precision is every 0.01 of a meter. So the absolute error is 1/2 times by that, gives me 0.005. So the upper limit is add it to your measurement, lower limit subtract it, and that is where you get these values here. So you'd find the upper and lower limit for each one. Do the same thing for the 8.3. You should get 8.25 and 8.35. So remember, area is just base times height. So for the maximum, I take the upper limit of both values. Okay, so I take my upper limit and my upper limit and I multiply them, base times height. That will give me area. Then my lowest limit, my minimum, I take my 2 lowest terms and I multiply them together, base times height. Okay, so depending on whether they say what is the maximum possible area for this, what is the minimum possible area, that's where you do it. So always break it up. Do the minimum maximum of the length and the breadth first, then times it. Don't times the 2 numbers, then do your minimum maximums. Okay, tough question though, that one. All right, let's keep going. Trigonometry is the next big one to talk about. I basically made this little flowchart. I quite like it. This will allow you to answer every triangle trigonometry question if you follow this flowchart. And you're probably thinking, how am I meant to remember this entire flowchart? But it's not as hard to remember as it seems. As soon as you're given a triangle, you say to yourself, is it a right angle triangle or not? Okay, that's the first question. So does it have the little box? So let's go along the left-hand side. Let's say it did have that right angle in it, okay? Then you say, all right, am I finding a side or am I finding an angle? So have they labeled it with an X somewhere on the side, or have they labeled it with the theta somewhere for me to find? Either way, you use SOHCAHTOA. Okay, every right angle triangle, you use SOHCAHTOA. And you just fill it into those formulas and rearrange. Depending on whether you're finding an angle or a side is how you rearrange them. The more common question to get is if it's a non-right angle. So it's just some weird triangle that doesn't have the right angle listed there. This is where you say to yourself, okay, am I finding a side or am I finding an angle? All right. If you're finding a side, then you have to say to yourself, all right, what's labeled? For instance, if I gave you this, notice how what I need to find is included when I'm talking about how many sides and angles are labeled. This question, I've got 2 angles and 2 sides labeled. So straight away, I'd say, okay, I'm finding a side that's down this angle, this arrow, and I've got 2 sides and 2 angles. So here's my formula. If, let's say, it was a little bit different. It had 3 sides and just 1 angle. And let's swap it up around this time and go, let's say they say theta, 4, 3, and 8. And they say find the angle. I would say to myself, okay, I'm finding an angle. I've got 3 sides labeled and 1 angle. So that's going to be the cosine rule. So the thing to remember is sine rule. Always use when there's 2 and 2. And cosine, you always use when there's 3 and 1. If you get stuck on your reference sheet, you do get the following formulas here. So you get your SOHCAHTOA. You get the area of a triangle that's non-right angle. That's the important one too. You get the side formula for sine, but then you get both sine and a side and angle formula for cos. So what you don't get is the angle formula for sine. So that's the only thing you don't get is this one here. But it's really easy to remember because it's just flipped upside down. And the other way to remember it, remember they're not telling me what each one of these formulas are for. This c squared equals a squared plus b squared minus 2ab cos c, it's used to find a side. And I remember that because it looks a bit like Pythagoras at the start, and we use Pythagoras to find the side of a triangle. Okay? All right, I'm not going to spend any more time on that because it covers all of it. The only extra part is your bearings, which people seem to not like, but bearings are just applying some harder trig questions. With your bearings, you've got 2 types of bearings. You have true and compass. The true bearing is always just measured from 0. Okay? 360. So if I gave you a line out to here and I told you this was 20 in here, the true bearing is just going to be the angle from 0 until you hit the line every time. So it's going to be 90 plus 20, giving me 110 degrees, and we put T for true. So then I could put one of those lines anywhere. I could say, okay, what if it's 40 in here? I say, all right, the true bearing is going to be this angle here. Remember, it's always a right angle in here, so you can say, well, that's all 90 degrees, which makes that 50. So I could do 270 plus 50, or I could do 360 minus 40. Either way, you'd get 320 degrees true. So they are your true bearings. The next one is your compass bearings. People usually don't like compass as much. So compass bearings. Let's say that I do the same ones I gave you up here. I have 20. With the compass bearing, you have the same angle sizes up here. This time I'm just going to label my northeast, southwest because compass bearing, you always need the quadrant it's in. Okay, so this one's in between south and east. So I write south, leave a space and put east. The first one you write is always got to be north or south. And I always remember it because they never say there's a east-southerly wind prediction coming. It's always southeasterly, okay? Or northeasterly, northwesterly. So you always have to put either north or south first. Now, this is the bit confuses people. I need the angle towards my line from the south to the east. So from the south to the east. Here's south, up towards east. Now I hit my line. So I need this angle in here, which, because I have a right angle, is 70. So I put 70 in here. So if I was just going to do my previous question up here, this one I say to myself, okay, I need the compass bearing of this line here. It's in between north space west, and I need the angle from the north towards the west. So start at north, go towards the west. That's the angle they gave me, which is 40. So that is your compass bearings. All right. The next thing, the big one, is perimeter, area, surface area, and volume, okay? This document here I gave you guys in my class. I will attach it to the video today, just in case you lost it. It has every formula you need to know in your area, trapezoidal rules, volume, and surface area, okay? Perimeter, it's basic, you just have to plus. So that's the thing to remember. The only other thing with perimeter is just remembering your circumference of a circle. But good news, up here they give you L equals theta on 360 2 pi r. So that is finding the length of a sector. If you don't need a sector, you need the length around the entire circle, which is called the circumference. It's just the 2 pi r part. All right, so this is something to go over, make sure you know all of them. I would be printing this out if you haven't already. Go through these formulas here, length, area, surface area, and volume, and look at what they actually give you. The worst part is though, none of these formulas tell you what shape it is. So you need to know what shape it is. So I would just spend this entire weekend writing these up in posters or palm cards and getting people to quiz you, okay? Just be mindful about your trapezoidal rule. That's always going to be asked somewhere along the lines. Remember, it's turning it into a trapezium, okay? H is the height. So when you have two applications, it means turn it into two trapeziums. So the height is each trapezium, not the entire height all the way along, all right? So you've got to halve that height if they give you the full length. And just be mindful if they say, it's the trapezoidal rule is always an approximation only because we're cutting it into trapeziums. So they could say, is this approximation larger or smaller than the actual area? And if we were looking at this first example here, we'd say it's smaller than the actual area because there's all that extra part there that we didn't account for. Volume. Volume's an easy one to remember. Okay, there's only 3 main formulas for volume, and you get 2 of them. So, volume of a prism is area times height. Area is always the area of the front shape. So you can see in those pictures over here, I shaded in the front shape. We call it the cross-sectional shape. Okay, so you find the area of that shape, multiply it by the big height, known as the depth going back into the page. Write the formula out. If you get stuck and it's a really hard volume question, just write the formula out. Pyramid, then, you just need to remember it's a third area times height. And I just remember it because it's dividing it up into 3. And pyramids involve triangles. And what do triangles have? 3 sides. That might be a long stretch, but that's just how I remember. Cylinder is a type of prism. Because remember, what defines a prism is the same cross-sectional shape all the way down. And it has that, but it's a circle. So this time when you do the area of the front shape or the cross-sectional shape, it's a circle multiplied by the big height. So a cone is a form of a pyramid. The base of the pyramid, which is the area you have to find, is a circle. So then the only other formula is your sphere. So it's not a hard thing to remember these volumes. AH is already there for the prism. A third is there for the pyramid, and 4 and 3 pi cubed for the sphere. Okay, and surface area. Surface area is usually your hardest one. Those ones there, what do you get given? You get given your sphere and your cylinder, okay? So you need to remember your cone. The rest of the surface areas don't have formulas because surface area of a cube, you just find the area of each side plus them together. All right, moving on. Where am I going? Here. All right, the last thing I wanted to just do a recap on is working with time. If you want to pause this video and give this question a go, see how you go with it. Otherwise, it was a while ago we did it, so I want to recap the little Miss Murray's technique that we looked over to make all of the questions a lot easier. Okay, the first thing I always say is draw a coordinate, okay, or at least a line, a number line somehow, but recommend the coordinate. Label what they give us. They say Karen's in Athens, which is 2 hours ahead of Greenwich. Remember, Greenwich is the UTC. That's where time is 0, okay? So it's 2 hours ahead. I'm going to label 2 hours, A for Athens. Make sure you put the name of the place on there because you will get confused otherwise. Marco is in New York, 5 hours behind. So here we have Marco in New York and it's 5. I'm not putting -5, I'm just saying it's 5 because it's 5 hours behind the UTC. Now, it says Karen is going to ring Marco at 10 p.m. on Tuesday, Athens time. What day and time will it be in New York? The first thing we need to know is, well, what's the time difference? Remember, join a line between the two places. Notice it's passing through my UTC line. I put a circle around that. See how there's a massive big plus sign? It's telling you to plus those times. So there it is, 7 hours. And in my HSC, I would 100% say 7 hours time difference. Show the mark of the time difference. It's part of working. If I had, let's just say, for question's sake, I had my 2 times on one side of the coordinate grid, my UTC. When I join my line, see how it's a big negative, okay? So that's where you would subtract the 2 times. So if this one was, say, 2 and this one was 10, you'd say there's an 8-hour time difference. So it tells you, it gives you the big minus or the big plus. All right, now I've got my time difference. I'm going to say, all right, 10 p.m. Tuesday. I'm going to write 10 p.m. and Tuesday. Make sure you write the day because you can forget the day and you won't get the mark right. And that's Athens time. So I need to go from Athens time to New York time. This is where this second little weird arrow things come in. I've put my arrow on here of what direction I'm traveling. I'm given Athens time. I need to travel this way to get to New York time. So my sign is a less than sign. A less than sign, I minus, according to my little formula there. So I know I need to minus my 7 hours. Okay, so it's as easy as that then. I end up with 3 p.m. Tuesday. And there's my answer. So that's for part 1. Part 2. This is where they add in a flight time or a train ride or a phone call duration, something like that. When they do that, you always add the duration. So make a little note on your summary, add the duration. So let's have a look. Now we've got Marco flying from New York to Athens. His flight leaves 9 a.m. WED in New York time. So this time we are going from New York time to Athens time, which means my arrow goes this way this time. I'm traveling from New York to Athens time, which means it's the greater than symbol. So this time I'm going to plus the 7-hour time difference. However, it says the time of the plane ride will be 11 hours. And what do I do with any duration time? I plus the 11. This next point I really want you to do because a lot of people miss this part. Notice now that's the same thing as 9 a.m. Wednesday plus 18 hours. Do not plus the 7, then plus the 11. It's twice as likely to make an error. Put them two together first. Then I get 18 hours. Now, I would usually do this next part in my head, but I'm going to write it. Think 18 is the same as plus 12 plus 6. If I plus 12 hours from 9 a.m., that's going to give me 9 p.m. still on Wednesday, but then I still need a plus 6. Now I just picture a clock in my head. If I have 9 p.m., I need to add 6 hours. That gives me 3 a.m. Now I'll be Thursday. And there's my answer. All right. Pause the video. Give this second one a go. All right. And here's your answers you should have gotten. You got them? Great. Close the video. Well done. Otherwise, let's just look through them. If you did it a slightly different way, also stay tuned. First thing, we said, okay, 16-hour time difference, I have to add it, okay? Notice I broke my 16 down into 12 and 4 because then I could flip the AM, PM and then just add 4. The next one here, we had to subtract the 16-hour time difference because we're going back the other way this time. But then 14 hours for the text message to reach him. What's the little trick? Put these together first. Do not minus 16 then plus 14. Okay, put it together. Negative 16 plus 14 gives me negative 2. So that's the same thing. Then it's just taking 10 a.m. Thursday and minus 2 hours. Now I get 8 a.m. Thursday. So that is the end of the video. So well done. Again, just a very quick recap. I would go through now and practice more HSC questions on all of these. Good luck.